Hey guys, thought I'd do a small code along exercise, and the example we're going to be using is one that we sort of skimmed over in class today about like a simple like recursive branching structure that was in the slides. So essentially what we're going to build up to is being able to create something that is complex looking as this with only like maybe a couple hundred, no, maybe 150 lines of code, and we're essentially going to be writing out this kind of basic workflow to take a line and then create some other lines about it, and then rotate it, etc., etc. And then we're going to kind of copy paste that into a function, and then we're going to call that function iteratively to create our recursive growth. So without further ado, why don't we get into it? So we're going to need to open up Rhino and Grasshopper, and I'm just going to draw a line like so. Oh, maybe I'm not actually. I might just reference it in. We'll see. Set one line. Oh yeah, because that's the way this rolls. Cool, and we're going to drop a C# component onto the canvas because we're going to be writing it in C#. And we'll hook our line up, and we will give it a type hint of a line, which is very important. And if we look back at our example, what else are we going to need? We're going to need a couple of factors here. A couple of inputs here. One's going to be angle. And again, we'll go from 0 to 2 point something. This is going to be in radian for now. It's kind of like the default measuring tool. Let me just call that line, and I'll call that angle. And just because I'm a stickler for capitalization, I'm going to have no capitalization. And then I'm going to have another one called factor, and another one called iter for iteration. It's important to go in and make sure the type hint is set to double for angle. The type hint is also set to double for factor, and we'll go for between 0 and maybe 2 point, I don't know, for factor. And iteration is going to be a integer in this case, so we'll go from 0 to 200. And plug that in, and this is going to be the basic building block of our workflow. What I might actually do is just do this a little bit differently so I can show you how cool it is. I'll set it up this way. Oops. What have I done here? There we go. Sorry, I just want to set this up in a certain way. Awesome. Awesome. Okay. So, we're now going to open up our code. And if I open that example back up, essentially we're going to go through and before I kind of copied this, but it needs a little bit of tweaking to put it back together into a code because it was a whole bunch of snippets that had been taken out. So essentially what we have to do first is find the start and end of our input line, I believe. But before we do anything like that, we have to think about end times. When I say end times, think about what is going to be coming out of our code. So I'm going to make a new list, which is what I'm going to dump all our created line segments into. When I'm finished, that's going to be up there, and then we're also going to find the start and end point of input line, and like I could just reference these points in, but we'll make it based on like the line. So whatever type of line you put in, we'll work it out. Point 3D, point A, we'll call it, equals, and because line is already a line, we should be able to pick up, should have a class that is we can call, and that should give us the point at which it starts. And I'm going to be lazy and copy that down, point B, and the end point is for 2. Awesome. And now what we're going to do is we're going to turn our input line into a vector. So that's, in fancier terms, calculate the vector which describes our input line. Cool. And that's just a vector 3D, and we'll call it VAB. No, we're going to write it like this. Equals, that's going to be equal to the point B minus point A.
Here's what I found on the web.
Oh, Google wants to chime in and actually help as well, if you heard that. Cool. Why? Oh, I forgot that we're going to write it like that. Awesome. So we've gotten this far, and we're going to calculate the vector of the first branch now. Let's do that by typing that out as a note so we remember it. Vector 3D, vector BC1 equals VAB. We're going to make it equal to our original vector. And then what we're going to do is, we're going to be tricky. VBC1, I'm going to rotate that around. Sorry if I write it properly. Rotate, angle, new vector. So we need to give it an angle, which is the angle we're putting in, right? And then because we need a place to rotate it around, we're going to rotate it around the z-axis. New vector 3D, bang, 0, 0, 1. Close that off, and then we're also going to times. So a vector is something that has direction, and a vector is something that has magnitude. So it's also give it a magnitude now, vector BC, and the magnitude is going to be the factor we put in here. So we're using the angle for what we're rotating around, and then the factor to control how long it is. Vector BC1 times by the factor that we input. Awesome. So we're slowly getting there. Now what we're going to do is calculate the vector of the second branch. And I'm just going to copy paste change numbers. Second branch, and let's just make sure I copy and change the right numbers. Essentially 1 to 2, guys. 1 to 2. 1 to 2, and first to second, which is done. And then now we find the new endpoints. Find the new endpoints of for our branches. And remember, it's really, really crucial that we're always commenting out our code to make sure that we can read it in the morning after we've been up late all night writing it. Point B plus VBC1, and we're going to find point, we'll call it point C2, so ABC, so we're kind of moving up, if you know what I mean. Point B2 equals point B plus vector BC2. Awesome. And now we're nearly finished. We just have to draw some lines now. Draw the new lines. And we're going to do, what are we going to do? We're going to go line branch 1 equals new line. It's going to start at point B. Point B. And it's going to go to point C1. I think. Bang, bang. And then we're going to do the same thing again. Remember, copy, paste. Change the right numbers. Change 1 to 2 and 1 to 2. Which should be okay. And then what are we doing? We're going to add the new lines to our output. So what was our output? The list we made at the beginning. Out list. Out list dot add branch 1. And what else are we going to do now? Copy, paste, change the numbers. Like that. Cool. And then we're going to make our output here equal to out list. By doing this. And I better put a space in there and like that. So that's kind of the basis of what we're going, well, of our workflow. What we'll do, just to recap, we dealt with some input geometry by getting lines to and from, calculated some vectors, which describe the calculated a vector of the original line as well, so that belongs up there. So let's go bang, 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 bang. Calculated the vector of the first branch, which is the same thing, rotated around and scaled according to our factor. Did the same thing, but for the factor. Because I forgot, we need to remember that one angle's going one way, one's going the other way, so we need to have a negative in there for the angle. And then finding new endpoints of these new branches. And then drawing some new lines, and then taking all those lines and putting them into our output list. Now I'm going to hit play and see if we've got any errors, and we probably do. Whoa. Let's have a look. Let's actually bring it over here so we can have a look. And again, vector is a type, but it's used like a variable line, 75. Okay, that's probably not good. Okay, sorry, I declared that wrong. Declared that vector wrong, declared that vector wrong. Oh, and that was all. Maybe. Oh yeah, so let's have a look. We're drawing some lines that are 0 millimeters long. Probably because our factor is 0. See that? So as soon as we put that factor into 1, and we start to do that, look at that, we've got, we have life. So what we're doing is by rotating the angle, I changed the angle, we're rotating the lines, right? So all from 0 to, is that 90? Is that 2 radian? I don't know. Doesn't really matter for now. And then we're changing the length of that by changing the factor. I know we're kind of running long, so in the next video, we'll essentially aim to recreate this pretty much by using the same code, but recycling it, which it's a very cheap way to create geometry. So I'll leave it there, but I'll see you in the next one. And remember to hit that like button if you like this kind of content and want to see more like code along kind of stuff, because I like doing it. It's pretty fun. Take it easy.